Okay, so for part C, it says the matrix T can be written as a product of three matrices, P times D times P minus 1, where D is the diagonal matrix. Write down the matrix P. Okay, now the reason we can write that down, or write down what P is this formula. So in the formula booklet, section 1.15, we have the power formula for a matrix, and when we've m to the power of n, it equals P times D to the power of n times P minus 1, where P is the matrix of eigenvectors and D is the diagonal matrix of eigenvalues. Now what that means is, let's write this down. The matrix P, this is easy because I have, so this is T from the previous part, previous video. These are the eigenvalues and these are the eigenvectors. So P is the matrix of eigenvectors. So P is equal to 3, 2, 1 minus 1, because my eigenvectors are 3, 2, 1 minus 1. That's it. Now you could put 1 minus 1, 3, 2, like put 1 minus 1 here and 3, 2 here. That's fine, but just make sure then that your D corresponds, because D is the diagonal matrix of eigenvalues. So this is important that the eigenvectors match with the eigenvalues. So if my eigenvector 3, 2, this is the eigenvector that corresponds to the eigenvalue 1. So the matrix, the diagonal matrix of eigenvalues, that will be my 1, 0, because the 1 corresponds to the 3, 2. And then the 0.5 corresponds to the 1, negative 1. So I have to put 0, 0.5 in this form because it's a diagonal matrix. So I have to have one eigenvalue here and one eigenvalue here and the 2 zeros here. Okay, that's it. 2 marks. Part D. He then says, hence find the long-term percentage of sunny days in Vokram. Okay, so if you recall from the previous question, guys, when I did t to the power of 3, I was able to get what's the percentage, what's the probability that it will be sunny in 3 days' time if it's sunny today. I could do t to the power of 7 would give me the probability in 7 days' time. Then I could do t to the power of 100 would give me the probability in 100 days' time. And you can imagine the probability of it being sunny in 100 days' time is probably the same as the probability of it being sunny in 1,000 days' time. Because when you look at really long-term probabilities, there's no way of predicting what's going to happen in 100 days more than you can predict what's going to happen in 1,000 days. So we end up with this kind of, what he's calling a long-term percentage of sunny days in Vokram. So what we do is we're just going to get t to the power of n, so t to the power of n, and we can write it using this. So it says hence, look, this is from this formula here. T to the power of n, it's not m though, it's t, is equal to p times d to the power of n times p to the minus 1. But I want it for when n gets super big, so I'm going to write it as n approaches infinity. Then what I say is t to the power of n, that's this to the power of n, is equal to p, which is 3, 2, 1 minus 1, d to the power of n. Now, what happens is, and this is one of the main reasons we have this formula is even useful, this to the power of infinity, if you think of 1, 0, 0, 0.5, a diagonal matrix, so this to the power of 4 is quite easy to do. It's just this to the power of 4, which is 1, the 0 to the power of the zeros stay the same, and then the 0.5 to the power of 4. So you just basically raise, 1 to the power of 4 if you like, you raise these numbers to the power of 4. That's how you get, because these are zeros, if you multiply out two matrices, that's just how it, you can try it if you want, try it with a few different numbers and you'll see how it works. So that's a diagonal matrix. So when I do to the power of when I do this 1, 0, 0, 0.5, when I do this to the power of, let's say, infinity, this is going to equal 1 to the power of infinity, which is 1, 0, 0, and 0.5 to the power of infinity. Now, what's 0.5 to the power of infinity? If you remember from your geometric sequences, or just kind of intuitively, if you do a half of a half of a half of a half of a half for forever, you're gonna end up with 0. So we end up with that. So this becomes 1, 0, 0, 0. And then p minus 1 is 3, 1, 2, negative 1 to the power, well, minus 1, the inverse matrix. And this, I can just do on my calculator. I'll do this straight like this. So I'm going to do menu, matrix, create 2 by 2, and then I'm going to do 3, 1, 2, minus 1, times menu, I'll do another one, create matrix 2 by 2, so this is 1, 0, 0, 0, and then times another one, menu, create matrix 3, 1, 2, negative 1, and this is to the power of minus 1. Press enter, and I get this 3/5, 3/5, 2/5, 2/5. So 3/5 or 0.6, 0.6, 0.6, 0.4, 0.4, 0.6, 0.6, 0.4, 0.4. So the long-term percentage, therefore, long-term percentage of sunny days is 60%. That's because this is, well, what this element means is if it's sunny today, what's the probability it will be sunny in, I don't know, infinite number of days, let's say 1,000 days. Well, 60%. This is if it's rainy today, what's the probability that it'll be sunny in 1,000 days? Well, it's also 60%, because think about it, the further you go away from today, the less the fact that it's rainy or sunny today affects the model at all. So these end up being the same. So it's 60%, and then this would be the probability that it will be rainy in, let's say, 1,000 days, which would be 40%. Okay, that's it. Hope that makes sense, guys, and I'll see you for the next question.